Okay, hi, Professor LaChene again. I'm now going to go over the Chapter 8 questions from the Math 107 Test 3 review, starting with number 5. And we're going to do the hypothesis testing here. And so starting with number 5, a recent study stated that if a person smoked, the average number of cigarettes he or she smoked was 14 per day. To test the claim, the researchers selected a random sample of 40 smokers and found the mean of the cigarettes smoked per day was 18. Standard deviation of the population is 6. At alpha equals 0.05, can the claim be rejected using a critical value? Okay, so we're going to go to the answers part here, the explanations. So it says that the study said the average number of cigarettes is 14. So that's what we're going to use for mu. That's what we're going to use for the null hypothesis, that the mean mu of the population is 14. That's what the claim is in the study. So it doesn't say anything about higher or lower. It just says, can that claim be rejected? So the alternative is that the mean is not 14. Could be higher, could be lower. That means the type of test that always matches to the alternative hypothesis, because it's not equal, is a two-tailed test. Could be more, could be less. So it's given to us that it says, to test the claim, there was a sample of 40 smokers. The mean of the sample was 18 with the standard deviation from the population of 6. That means we're going to use a Z distribution because we know the population standard deviation. Alpha level of significance, 0.05. And so can the claim be rejected? If the claim is the null, you talk about rejection. So the next thing we have to find is the critical value for Z. And so because the level of significance is 0.05 and it's a two-tailed test, we have to split that half of 5% between each tail. So it's 0.025 in each tail. And in order to find the critical value in the Z distribution, it's easier to look up the left tail. It's just a little more direct. And I'm looking in the area for 0.025 on the negative Z side. And there happens to be an exact match. There isn't always, but there's an exact match at 0.0250 right here. And so that's at negative 1.96 for the critical value of Z. There is a chart on page 422 in the book that gives these common critical values that also tells you, because it's a two-tailed test, we have to use plus or minus 1.96 for the critical values that separate the rejection region for the null from the do not reject. So now we're going to calculate our Z-score using our Z-score longer Z formula that we learned back in chapter 6 for the central limit theorem. So that is mu, which is 18 here, minus X bar, sample mean 14, over the population standard deviation 6, over the square root of the sample size, N is 40. So first subtract. Then remember, you want to use parentheses when you put all this in your calculator so that it gives you the correct order of operations. And this should turn out to be approximately, to 2 decimal places for your Z-score, 4.22, which is a very large Z-score. So 4.22. So the larger the Z-score, the more evidence there is to reject the null hypothesis. So if we could then go and locate this on the positive Z side, it's way, way, way even farther over here than I put it. Positive 4.22, it's in the shaded rejection region, which means we reject the null hypothesis based on the sample that was taken. We're going to reject the null. And if we reject the null, that means the evidence favors the alternative, the H1. And so the question was, is there enough evidence to reject the claim? The claim was the null. Based on the decision, we rejected the null. So there is enough evidence to reject the claim. And it seems like based on the evidence that the mean number of cigarettes smoked is not equal to 14. Now it's not proven, but based on the evidence, it seems like it lends itself to the alternative hypothesis rejecting the null, but the evidence favors the alternative. So if we go to number 6, it asks us to do that same question, but this time using a p-value instead of a critical value. So again, we're going to use mu equals 14. The null is the same, mu equals 14. That was the claim. The alternative is that it's not equal to 14 because it didn't say anything about less or more. And so the type of test matches to the alternative because we're checking for rejection of the null. So it's a two-tailed test because the alternative has not equals. They told us again that the sample size was 40. Remember, the sample mean was 18 and the population standard deviation was 6. So again, we're going to use a Z distribution to get our p-value. The level of significance was 0.05. So what we do is calculate our Z-score, which again, we take mu minus x bar over sigma over the square root of n, use parentheses. Again, we get 4.22, but because it's a two-tailed test, we have to say our Z-score is plus or minus 4.22 when we're looking for our p-value. So now we go and draw and shade negative and positive 4.22, and these shaded areas, because it's a two-tailed test, each is half of our p-value. So again, it's always easier to look up the negative one. And so if I try to look up negative 4.22 in my Z distribution, well, the smallest value I can look up for Z is negative 3.49. And that gives you an area in the left tail, because you always get the area to the left, of 0.0002. So because negative 4.22 is even a lot smaller than that, we could pretty safely say that the area in the left tail is probably 0.0001 or even smaller. And so our p-value is 2 times, it's 2 times whatever amount of area we say is in, sorry, here, 2 times whatever we say is the area in the left tail. So I would say that probably it's about 0.0001, and then over here the same 0.0001. So for our p-value, I could either add those together, multiply by 2. If you kept the 0.0002 in each tail, multiplied by 2 or added together, you get 0.0004, which is fine. You're still going to get the same decision. When you're using a p-value, compare p to alpha in that order. So I'm going to add a 0 in front, and on alpha, I'm going to add some zeros behind. And we go left to right. The first difference is in the hundreds place. P is you're looking for, is it less than or equal to or greater than alpha? P is less than alpha. So that means we are likely not making a type 1 error or rejecting a null hypothesis. That's true. We could go ahead and reject the null hypothesis, H sub 0. That was the claim. Is there enough evidence to reject the claim? That was the null, so there is enough evidence to reject the claim. Whether you do a p-value or critical value, you should still get the same decision and an interpretation in the hypothesis test. Now let's go to number 7. Number 7 says nationwide graduates earning in the actuarial field earn $40,000. The college placement officer claims the actual earnings are higher than $40,000. So that's our claim that the mean earnings are higher than $40,000. She surveys 36 graduates entering the actuarial field and finds the average salary is $41,000 with a population standard deviation of $3,000. So again, a Z distribution because we know the population standard deviation. Can the claim be supported at alpha equals 0.05 using the critical value? And then we'll do it again with the p-value for number 8. All right, so let's write down what we have. The claim had greater than, so that's the alternative, the null always has equals, that the mean earnings are higher than $40,000. That was the claim. Because the claim is the alternative, we talk about support in our interpretation. So the null is that the mean equals 40,000, whatever you're comparing it to here. So that's what we're going to use for mu. The type of test matches to the alternative, the H1. So it's a right-tailed test because again, the alternative is where we reject the null. That's what we're testing for. The level of significance they gave us was 0.05. And there was a sample size of 36 with a sample mean of $41,000 and a population standard deviation of $3,000. So what we're going to do first is draw and shade, and we have our mean in the middle. It's a right-tailed test. What we put in the right tail is our level of significance alpha 0.05. So if I want to know this critical value, which will be positive, I actually need to know the area to the left, 0.9500. So I'm going to look on the positive Z side of the table. I'm looking for 0.9500 to the left. There is not an exact match. We have two choices here. We have 0.9495 and 0.9505. Your book picks the bigger area. Some books pick the smaller, some split the difference. That's a z-score of 1.65. Again, on page 422, they have those values actually listed. So we're going to use 1.65 for our critical value of z. 1.65, which separates the rejection of the null region from the do not reject region. So there's our critical value, 1.65. So now we're going to calculate our z-score by taking, again, the longer z formula, mu 41,000. Sorry, x bar, I think I said that wrong. X bar 41,000 minus mu 40,000 over sigma 3,000 over the square root of the sample size 36. So it's x bar minus mu over sigma over the square root of n. So that's going to give me 1,000 over 3,000 over the square root of 36 is 6. And you can do this calculation here and get 500. It's easier not to have to put all that stuff in your calculator. So what we end up with our z-score is 2.00 positive. So then we go and locate it in the drawing. And the question is, does it fall in the non-rejection region or in the rejection region? Well, 2.00 is farther over to the right here. So it's in the rejection region for the null. So our decision is to reject the null. Remember, the claim was the alternative. So if we reject the null, it means the evidence supports the alternative, which is the claim. So there is enough evidence to support the claim that the college person said that the mean earnings of actuarial people entering the field is more than $40,000 based on the evidence collected. So now we're going to do that same test using a p-value, same hypothesis test, but now with the p-value. So again, our population mean mu was $40,000. This is number 8. That's what we're going to use for the null. Remember, the claim was that the mean was higher than $40,000. Sorry, I put the wrong number here. Let me make that $40,000. That's the claim here. And so that's going to be, we're going to talk about support. The type of test matches the alternative hypothesis, which is because it's greater than, it's right-tailed. Our level of significance given is 0.05. And they told us the sample size was 36. The sample mean turned out to be 41,000 with a standard deviation of the population of 3,000. So again, using a z distribution to find our p-value. So we're going to calculate our z-score, taking x bar sample mean minus mu 40,000 population mean over population standard deviation sigma over the square root of n, the sample size. We're going to get the same answer here. First, you take the square root of 36, then you divide here, which gives you 500, gives you 2.00 for your z-score. Now to find our p-value, we put 2.00 for our z-score here. It's a right-tail test. So actually what we're going to do is we're going to go look up 2.00 in our positive z, 2.00, which gives me an area to the left of 0.9772. That's the area to the left, because that's how our table works. But our p-value is the area to the right. So we know that the total area under the curve is 1. We take 1 minus the 0.9772 to get the right tail of 0.0228, which is our p-value. So I'm going to write that over here. So for our decision, we compare p to alpha in that order. P, I'll put a 0 in front. Alpha, I'll add some extra zeros. And is p less than alpha, equal or greater? Well, if you go left to right in the hundreds place, 200 is less than 500. So p is less than alpha. When p is less than alpha, we're probably not making a type 1 error, rejecting a null that's true. So we can reject the null. And when we reject the null, the evidence supports the alternative, which is the claim, or the evidence leads to the alternative. So there is enough evidence when we reject the null to support the claim that the actual earnings are higher than the mean, 40,000. So let me do number 9, finishing up chapter 8 here. In number 9, it says the CEO of a large accounting firm claims that the mean workday of a firm's accountants is less than 8.5 hours. That's the claim. Less than, that's the alternative hypothesis with less than. A random sample of 35 of the firm's accountants has a mean workday of 8.2 hours, so X bar, with a sample standard deviation of 0.5, so that's S, because we're given a sample standard deviation, we have to use the t-distribution for this problem. And the next one, at alpha equals 0.01, can the claim be supported? Use a critical value, and then we'll do it again with the p-value. So going to number 9, we are saying that the claim is that the mean is less than 8.5. That's the claim, which makes it a left-tailed test because of a less than in the alternative hypothesis. For the null, it always has equal, mu equals 8.5, whatever you're comparing it to. So that's what we're going to use for mu. The type of test, again, is left-tailed. So we're going to use a critical value here, a left-tailed test. The sample size was 35, which means the degrees of freedom in a t-test in a hypothesis or confidence interval is n-1, sample size -1. So our degrees of freedom are 34. It's a one-tailed test for 34 degrees of freedom, and alpha equals 0.01. So we're going to go to the t-distribution. For one-tailed test, alpha equals 0.01, 34 degrees of freedom. Okay, so 34 degrees of freedom, 0.01 in the one-tailed test, we get a critical value of 2.441, critical value for t. But because it's a left-tailed test, because it's in the left tail, we're going to call that negative 2.441. And we're going to go draw that, negative 2.441, and we're going to shade, okay? And that is our rejection region here. What's if we calculate a t-value and it's in the rejection region, we reject the null. If it's anywhere over here, we fail to reject or do not reject the null. So we're going to use the sample mean 8.2 minus the population mean 8.5 divided by 0.5, the sample standard deviation, divided by the square root of the sample size 35. Again, use parentheses. First, subtracting the numerator, negative 0.3. If you put this in your calculator, you're going to get a t-value of negative 3.55, which you now locate. It falls in the rejection region. So our decision is to reject the null. If you reject the null, that means the evidence favors the alternative, which is the claim. So is there enough evidence to support the claim if you reject the null? Yes. You reject the null, the evidence favors the alternative, that is the claim. So there is enough evidence to support the claim. So we're going to do this one more time, but now do p-values with our t-distribution. So again, the claim was that the mean of the population is less than 8.5. That's the claim, which makes it a left-tailed test, less than an alternative left-tailed test. In the null, we have mu equals 8.5. That's what we're going to use for mu. The null always has equals. The type of test, again, is left-tailed. It says using alpha equals 0.01 here. That was given. So now what we're going to do here is we are going to find our p-value in a left-tailed test. And so what we have to do is we have to calculate, and we have 34 degrees of freedom, by the way. So first we're going to calculate t, n-1 for the degrees of freedom. We're going to take our sample mean, 8.2, minus the population mean, 8.5. That gives you negative 0.3, divided by the sample standard deviation, 0.5, over the square root of the sample size, 35. Again, that's going to give you negative 3.55 when you put that in your calculator. And so over here, I forgot to finish here. I'm going to put this way. Oh, it's really even farther than that. It's a left-tailed test. So this is my p-value, whatever's in the left tail, whatever here, okay? But we have to use the t-distribution to find what our p-value is. And so we go to the t-distribution, and we have 34 degrees of freedom. We're looking for negative 3.55 and 34 degrees of freedom here. We're looking for negative 3.55 in a one-tailed test because it was a left-tailed test. So we look at these t-values, we're looking, where does negative 3.55, actually it's 3.55, we're going to do an absolute value. Does it fall between any of these? It actually doesn't. It's actually even farther over here. And so at a p-value of 0.005, you've got a t-value of 2.728. That means our p-value is even smaller than 0.005. So that's where we get that our p-value is something less than 0.005, 0.5%. So if we compare P to alpha in that order, it's even smaller than this, but it's okay. It's close enough here. We take 0.0050, compare it to 1%, 0.0100, level of significance. The first difference is in the hundredths place. Again, P is less than alpha. When that's the case, we reject the null hypothesis. That means the evidence favors the alternative. When you reject the null, the alternative is the claim. So, and we talk about support when the claim is the alternative. So we're rejecting the null, the evidence favors the alternative, which is the claim. So there is enough evidence to support the claim using a p-value. Again, either version, whether you're using a critical value or p-value, should still give you the same decision and the same interpretation. So that's the end of the chapter 8 questions. I'll stop this video and then I'm going to pick up and do another video for the chapter 10 questions from the test 3 review. So that's the next video.